Hi everybody, this is Mr. Westfall. We're going to continue with our 22.2 notes, and we're going to start on under the conduction heading, number 25 on the back. So number 25. And we're talking about conduction here. If you recall, there are three ways that energy can move around the universe. Conduction is one of them. So conduction is the transfer of heat by contact or touch. So conduction is a transfer of heat by contact or touch. So think of a pot on the stove. If there's food, let's say I have a T-bone steak in here, it's going to heat up because the coils from the electric stove are going to touch the pan, and the pan's going to touch the T-bone steak, and it's going to heat it up. So it's a direct vibration of molecules from here to here to here. Okay, so that's conduction. So how does it factor into weather and climate like we've been talking? Well, it turns out that the ground and the oceans heat air molecules by the process of conduction. So if I have cold air sinking, if I have cool air that is sinking down like this, and to select black there we go. If I have cold air that's sinking down, since heat always moves from hot to cold, if this land here is warmer, the warmer land is going to touch the cooler air, it's going to heat it up, and it's going to cause it to rise. Okay? So that's another way that heat moves around. We'll talk about that in a second. So, as heat begins to rise, it does so because it's warmed. So the air rises up. And we already know, and this time we're going to write down officially, that as hot air goes up, it begins to cool. Cool air can hold less moisture than warmer air, right? Right. But what happens when it gets to the top and it cools? Well, as it cools, it's going to sink. And then it's going to hit the ground again, and it's going to get heated by conduction, and then it's going to rise back up again. So conduction is important to the cycle of air going up and air going down. And, of course, what do we call that? We call that convection. Convection is hot stuff up, cool stuff down. Now what we've done is we've added conduction to the equation, because when it gets to the bottom of its cycle, either the water or the land can heat up that air so it can rise back up again. So it turns out that this is an important thing for the cycles that happen on planet Earth. Okay, so it's similar to water boiling in a pot. Hot stuff is going up, the cool stuff is going down. So the warmed air is less dense than the air above it, so it rises up. Warmed air is less dense than the air above it, so it rises up. And as it rises, it begins to cool. The cooled air sinks to the ground and is heated by conduction again and rises again. Okay, this is going to happen in your beaker in the chemistry lab. Here's your heat source. By the way, this is radiation because a flame is plasma. So this is radiation here. But once it touches this, the water is getting heating by conduction. But the reason that the hot stuff goes up is because conduction. So hot stuff's going to go up, and the cool stuff is going to go down. Okay, so remember, three ways that heat moves around the universe: radiation, conduction, and convection. Okay, So if we take a look at this, we've got ourselves a pot. Let's relate it to something that we do every day. We make food. So inside the pot, that's convection. The fire itself is heated by radiation. So flame is radiation. The EM waves coming from the sun, that's radiation. And once the heat comes up and heats up the water, and then that water touches the metal, and the metal touches your hand is going to get warmed up and eventually burned by conduction. And that it should be the end of our show here for 22.2.